is my latest project, and as you can tell, I decided to recreate Velocicoaster, but this time, instead of making a powered coaster, I chose to make a model where the motion of the trains is represented by an LED strip that runs throughout the entire track, and I have a simulation and a little microcontroller that can move the sort of trains across and make it look really cool. Overall, there's about 3,000 LEDs spread across, I think this track is about 9.25 meters long. The scale is roughly 153 and a half. I say roughly. But the track is much larger than it's meant to be, so it could fit the LED strips inside. And then it looks all really pretty, but you can't tell that the LED strips are like actually on the inside. Overall, it's about 64 by 34 by 14 inches tall, and I intended to make it wall mounted and also be really quiet, because my powered coaster model, although it is really cool, it's a lot louder than I would want to be if it was running permanently, whereas this is completely silent. The terrain is all routed out on my CNC machine out of plywood. The buildings are made of foam, also routed on my machine, and the track and supports are all 3D printed. Overall, there's like 128 individual support pieces, and then 59 track sections. Here's just a few. Watch a train go around. It's been about 6 months that I've been working on this, which is kind of funny because that's about the same time frame that I made my other model in. And I talked about it being a realistic speed, but in this case you can tell it's going a lot faster than the real ride. This is actually 3 times speed, but I chose to do that instead because I wanted it to look really interesting, and you couldn't get as much visual out of the speed variation when it was going to realistic speed. I can show you what that looks like. I have a little remote control that I can use to turn it on and off, but I'll put it back to 1x speed, and now it looks like it's just crawling through. So yeah, I like to leave it. Well, I'll show it going through the launch right here, because that's where you'd be able to tell. Of course, it's not going to follow the exact timing of the real ride, because I do the simulation based on the shaping of the model that I ended up with, but it's pretty close. Let's put it back up to the faster speed, because that looks much more interesting. Yeah. Next up, I'll take you up through my entire process for designing this model and give you the behind-the-scenes look at it. Okay, here we are in Rhino. This is where I designed the entire model, and as you can tell, it's all blank. But the first thing I did was I found a reference picture that could show me sort of the shape of the track. This one I found on Google. It was the proposed sort of layout. I don't know how accurate this is or at what stage in the overall project this was, but it was certainly a good enough model to go on. So the first thing I did after that was I sort of scaled it based on some Google Points lengths and distances that I found. And so I was going to recreate the whole layout in full scale, and then I could scale that down to whatever I wanted the model to end up being without affecting any of my measurements. This would make it easier also, so I could have the references of like how long it is and how tall it is already in the model, instead of having to adjust that based on a scale also. So the next thing I did was I traced out this yellow path of where the ride was, because I knew from the top down that would give me a shape that's roughly correct. So here's the center line on that. It's a little hard to see, but I just traced it out with a spline, and then obviously some lines in a few places where it was straight. But that would be the shape of the track as viewed from the top. And then what I ended up doing for this system was I would draw this and then consider like an imaginary surface going vertically into the screen right now. And then I could draw a profile along that surface, which would be along the track. And that would give me the elevation of every spot. And then when you combine those two, you would get a 3D centerline. So down here is also the profile view of it, sort of unrolled into a really long single curve. But like right here, you can see the peak for the top hat, the flat launch right before it, and then of course like this is all the paddock area. Yeah. So the result of combining those, if we go into 3D and show the centerline layer, we get, yeah, we'll leave it in that. We'll get these, at least we'll get this one centerline. These guys we'll talk about in a little bit. But yeah, so this is how I did the shaping. I just sort of iteratively got it better by hand based on some reference pictures. Like on Google, there's some pretty nice pictures of the layout from this angle. I saw a few from over here. I think BioReconstruct was where I got a lot of those pictures from. He had a lot posted on his Twitter. Yeah. So once I had a centerline I liked, I also was working on the banking to make it match up, and I almost implemented the same system as No Limits, where I could put roll nodes along the track, like these guys, and I could say at that spot I wanted it to be banking a certain amount. And that was just controlled by like the little object properties on each of these guys. And that got me to this. So you can see based on these reference curves below the center line, that's how I ended up with the banking. And now I guess we'll get on to actual track. Let's see. I had this center line, and then I also had a prototype version of a sort of track meshing or track geometry generation that I just plugged in the centerline information to, and I got something that was roughly what my model would end up looking like, and then from there I could decide on a scale that would be realistic for fitting the LEDs on the inside, as well as giving me a model that's not too big. So here, if I show the frame, I sort of just oriented this to fit in a rectangular area that wasn't, and then the size of that rectangle is just based on how much or what scale I wanted to end up using. In this case, I went with 153 and a half. So it's 153 and a half times smaller than the real thing. And then here would be the 3D models of the track. These are the final versions, which are meshed with like the final measurements and everything. Each of them is a single solid body. The very first prototype I had, of course, didn't have these support interfaces because I didn't make any models with supports yet. But it also didn't have this second spine that you see going through the like on the top hat, and then also in this helix area where the real ride would need higher strength to support these longer support spans. But yeah, there's a nice touch that made it look a whole lot prettier, I think. So I meshed all these track pieces, and then I knew I would need supports, and I thought I wanted to do that as simply as possible, where I could just basically draw the center lines for every single beam that would exist in the model, and then let a little system automatically group them together and generate the solid versions of them. So I spent a few days, I don't actually remember how long this took, but hide the center line, bring up the supports. These are the center lines on the supports beams that I ended up making. It took a while to draw them. I really thought I liked the ones that had lots of beams all connected into larger structures. Those were really fun to make, and I thought they ended up looking really cool, like these towers. Of course, these are only center lines, but you'll see the geometry versions of them soon. And for the supports, can't forget footers. So I also set just points on the end of these where I wanted to generate a footer that would go down and extend to the ground. Yeah, and then you'll see over here, I actually fused some of the footers directly to the track pieces just because it's so low to the ground that it wouldn't have been very realistic to, actually it would not have been large enough to fit the same interface that I had everywhere else. And it also just meant less pieces, so that was convenient. Here is the models of the supports. So you can see they just exactly represent the center lines that they cover. I just go into wireframe mode. You'll see some of the edges, just how Rhino chooses to place the seams on these, but the center line defines where the whole beam goes, and then they get automatically grouped so that the solid unioning works between the actual B-reps. And I think on that, I ended up having to do sort of like a little fudge factor where it would slightly adjust the radius of the beams, an imperceptible amount, but enough to where the edges would actually be able to be computed because of Rhino's tolerance. I kept getting errors if I tried to use all of the same radius on a beam in these large structures, but that little fix made it work and is not really anything you would really notice. So that was good. And as you can see here, it's generating these footers all at the associated points, which are just on the ends. And then it also joins those to each model. And the system also will identify from the bottom what number, that's pretty easy to see. Also give each footer a number based on where it connects on the track. Or not where it connects on the track. It'll give this entire support structure a single number, and that's based on the very first spot that it touches the track, and that would let me, because there's 128 support pieces that all look pretty similar, like all these guys right here, which are just getting slightly shorter. That would let me identify them and then put them in the right places without making any mistakes. And of course they're identified from the bottom because that's where you would read them from. Yeah, there you go, that's a little bit easier to see. Yeah, and you can see that I didn't quite match the actual layout, like over here. That doesn't follow this assumed barrel roll or mosasaur roll because I wanted that shaping to look a little nicer from this perspective, and I ultimately have to make something that looks good on the model and assume that it'll be, and just know that it's going to be close enough to be deemed accurate. But that was one little spot where I slightly messed with the shaping to make it look smoother compared to what would have happened if I just followed this yellow line arbitrarily. I think I did a little bit of adjustment also on the entrance to the top hat, but that's not very noticeable. It just still makes it look nice and smooth and kind of close to the reference pictures. I think I did a pretty good job overall matching the shaping on the whole layout. And actually now, I skipped over this, but these extra lines that I mentioned, those I was actually using so I could perfectly snap all the supports onto the spine wherever it was. So as you can see here, this extra reference curve is going through the entire layout, and then I just use it where I knew that I would have, or where it generated the double spine, and that would connect the support to the double spine instead of the single spine and not have any interferences or anything. And then like in places where it doesn't have a double spine, I connect to the rail sort of that's going through the main spine. And so that's where obviously the majority of these are connecting. As you can see, this is a special one, I think. Yeah, this is a special one. Some of these were like short enough where I just didn't really think it was necessary, or it would be easier to just define like, I want a footer that's right at this point. I call these direct, oh, I can't select that because it's locked. I call these direct footer points, where it would just use the orientation of the track and then project a footer down following that same orientation until it hit the ground. Yeah, that just made it easier, so I didn't have to draw like a really tiny green line, which would not have been very useful. That's what I used over at these guys, where I just put a direct footer, and then in this case, because it was short, it got automatically joined onto the actual track section. I guess the big thing that's missing from this is the terrain. So I will go into this rendered view. Rendered view looks nice with the white track as reflected on the model. I'll hide all these guys and show off how I made the terrain. So first off, what I did is just went into like paint and drew a, oh yeah, it has to be rendered. Drew a height map sort of, and smoothly starting from over in the paddock area where it was higher, and then sort of going off down to the water level just gradually. And then I imported that into Rhino as a height map, and that gave me this surface, or the first version of this surface. And then from there, I realized I could start just, if I turn the points on, I could start editing just the control points to get any extra shaping I wanted relative to the actual track geometry, which I wouldn't have had if I was just working inside of a paint program. So that's where I got this little dip where it dips down to the start of the second launch tunnel. And then as you can see, the buildings aren't cut out yet, but it's just sort of some gradual terrain that would look nice. And then I turn those points off. I section this surface at like a series of planes along the z-axis, and then that gives me a bunch of curves, which then define the boundaries of the layers on the terrain. So that gives us these outlines, of course, minus the buildings, which it wouldn't have considered at that point. But then I just take those outlines and then extrude them into layers, and now I have one solid piece of terrain that is made of contours. Gives it a really nice terraced look. And originally I used to have a lot more lines or more layers on this, but after I was having a lot of trouble with how I was ending up doing the terrain, I decided I wanted less layers, and that actually made it possible to do in the plywood that I had, or the plywood that I ended up with. There it is in tan to match the plywood. After I had all those layers, I set up a thing to generate the buildings, and that was really just drawing, not that one, not that one. There we go. Drawing the outline of like what I wanted that station building to have, and then I also traced out the outline on the Discovery Center, and then had it generate like a symmetrical version of that across this center line. And that gave me these areas where I could cut out the correct regions and then fit those buildings in once I generated them. And let's see, this would be those buildings. Yeah, they fit nicely in place. I also did this cutout for the launch tunnel. That was just based on the an extruded profile along the center line at that spot. And then I also did this cutout just drawn in by hand as where I wanted this trench to fit the track around. And I just made sure that it wouldn't interfere with any of the supports or anything around there. So that gives us this overall model, which looks pretty good. And then of course, it's framed, so we will show the, where did I put that on? There we And that's our 3D version of the model, which ended up looking pretty close, or the other way around, the real version ended up looking pretty close to what I was hoping for. One thing you might notice is the footers over here that would be above the water line. They're actually visible here, but on the real model in person, I ended up not having that because I wanted a way to locate these accurately, but still have them connected very strongly to something. So I ended up just drawing in an extra, I'll hide the surface, an extra piece that I would cut out based on this outline, and that would let me also route out a reference of where all the footers above the water should go, and because it was because I didn't originally plan on it, the footers no longer stuck out above the water, but it was such a minor detail that I didn't mind it, and it blends in pretty nicely just because I also painted it black. I forgot to mention this, but as you can tell, this terrain model doesn't have any holes in it, whereas the actual footers do extend down inside of it, so they can get located. I ended up, because I had so many different ideas of how to do this terrain, and I would try one way and that didn't work, so I had to end up doing it differently. The layers kept getting slightly different, so I kept the holes separate, and then I could just cut them out after anytime I decided what the layers were going to end up being. My original plan for the terrain was to route it out of insulation foam that I could easily get at Home Depot and fit on my CNC machine. And that I could get 1-inch thick sheets that were 2 foot by 2 foot. So I was essentially just going to split up this model into 3 pieces. The original one was slightly bigger than this, but I could get this 2 foot by 2 foot sheet and roughly get like that guy, and then split up the other half of it into 2 separate pieces, just because they were right on the edge, and I would still need work holding, like screws to hold this down to the bed. But after I tried out this piece of it, I realized that I wasn't very happy with how much time it was going to take to make something that looked really good. So I ended up just it would take a lot of time of finishing and sealing the foam. So at some point I'll have to learn a better way to deal with that. But I ended up just switching to CNC routing plywood layers, and of course that fits very nicely for this model because it is made of layers. And now you can see there are these holes here that represent where the footers go. As I said before, they get joined in afterwards because I was changing the terrain so many times. I just needed something that was consistent, and I would know it was always based on the original pieces that I got printed, because I got those printed before I ever even started working on the manufacturing the terrain. And here you can see that extra piece that I cut that's above the original water level, which was just this ground plane right here. So it covers those footers, but it gives me accurate placement relative to the entire model. So one issue with this is I can get a 2x4 sheet, 2 foot by 4 foot, and fit the terrain, or the terrain didn't fit in there previously, so I had to shorten it down just a bit to where this main piece would fit inside, and of course this part doesn't, so I had to cut that off, and that would be pieces that are separate, and then there would just end up being a seam on the final model. But so I ended up using 2 foot by 4 foot sheets, and the issue with these was I could fit them in my machine, but I didn't have the work area to actually route out over the entire thing. So in my experience with using Fusion 360 and stuff for doing cam, I knew it was going to be really annoying to try and set up, do multiple setups and cut out half of each layer and split the models by hand so that it didn't try to cut through the half and then leaving me with 2 separate pieces and a seam in the middle and actually some kerf cut out of it so it wouldn't be accurate anymore. I set up a system in here that would automatically generate those two sort of setups for a given sheet. And then I could just run one half of it and take the sheet off, flip it around based on some dowels that I put into the bed on my machine, and then run the other half, and then that would sort of finish off the entire cut in one piece. So the result of those is, well, here are the individual layers, all in their own place, and then here's where I could define a sheet. So I just grabbed, like, I guess I didn't copy it, but this would be the very lowest layer, and the second layer, and the third layer. You can see these are where those, I think those are actually alignment. Yeah, I'll get to those later. But I could define points where I wanted to be able to put screw holes, and then I would be able to safely let the machine drill in those spots, and then I could put screws, and then know that I'm never going to be in a spot where I interfere and like run the tool through a screw, and then everything just gets all messed up and the bit breaks. But I would define my sheets and put my pieces into them, and then the system would overlap all of these, so it's not easy to see. It would give me these sheets as the output, where it automatically cuts it across the middle, and there's a little bit of overlap. So if I rotate that 180 and then match it up on here, they overlap each other, and that lets me know that I'm in the same area. So when it runs over the, like, after it cuts this half and it's going to run this job, it's going to start cutting right along this little edge, and if that doesn't make a lot of sound, then I know it's not cutting a lot and I have a really good alignment. So that was just one little thing that let me check that. But that would have been really annoying to try and do by hand in Fusion and get all these pieces set up and then like map all these holes across. Yeah, so I just ended up doing this, and that gave me all 8 of these guys. And then I, of course, added the 9th sheet afterwards, which had to have the same sort of double setup per sheet. And in this case, I included the holes because the geometry wasn't very complicated, and it's only one piece, so it can have the holes cut out. And that's the result over here of being split up into 2. And this is the same thing where it matches up with a little bit of overlap. I wanted to cut the holes afterwards, not in each individual layer, because I knew when I was gluing, I wouldn't necessarily be able to get a perfect lineup. And if I didn't get it perfect, then the supports would be extremely difficult to push into those holes. So I left these 2 holes on the bottom layer or I guess bottom 2 layers that would let me, once I glued all of the layers together, relocate the whole sort of assembly onto the bed in the same sort of setup location as I was using for every individual sheet. And then, because I had the whole information, I could just generate a model and run the cam and generate the tool paths to cut the holes, and it would just assume that it had the entire model, because at that point it did. And then all my holes would get cut perfectly relative to every single layer. And if it was a tiny bit out of alignment with the whole model, that doesn't matter, because the holes are all perfectly oriented relative to each other, because the machine cut them exactly that way. I did notice that I probably should have put a little bit of an offset edge on this extra piece, because it didn't quite fit around the terrain down here, but it fits good enough for all the pieces to match up with each other, and that was all that really mattered. And plus, when it's painted black, it blends in with the bottom, so you really don't even notice where there's like a slight gap. I think in this, thinking around this area is where it had a little bit of a gap to the actual terrain. But that does make sense, because these bottom pieces, this is actually the cut that it did to separate the main chunk of the terrain from the little pieces that extended over on the bottom 1, 2, 3, 4 layers, 3 layers. Yeah, I think, yeah, I went with, yeah, the bottom 3 layers because the fourth one was inside of the boundary of the sheet. Yeah, that's how I dealt with the terrain. And then I just ran these setups on my CNC machine, did the gluing, cut the holes out, and ended up with the model I have now. As for how I actually dealt with all the LEDs inside of this, I found some really small 4mm wide LED strips that I ordered on AliExpress, and throughout the entire thing, I think there's 21 of them that I used. And based on the overall number, if they were all in one single strip, one after the other, the frame rate would have been like 12 frames a second. But as you can tell, this animation is running a lot smoother than that. I ended up splitting the whole track into about 5 different chunks, each with roughly 4 strips of LEDs worth soldered together. And you'll see, like right here is one spot where a fresh sort of chunk starts, and a fresh signal and power and ground are provided to that chunk right there. And then here's the next one where it starts at somewhere in here, but the wires are small enough where they can fit inside the track, and then the train just sort of passes over it. Of course, the first one can start on the inside and just be hidden. And here's another one. There's a chunk that starts roughly around here. The wires all just go from the backside through these holes and then come up inside this building, where they all get connected to the little CNC microcontroller. And of course, there's a little IR receiver that is temporarily right there. I'll put it into a nicer spot. But yeah, that's a little view of the electronics and wiring for the LEDs. I realized I didn't say this, but the CNC actually controls all 5 LED strips, or sort of chunks, in parallel across 5 different data pins. And that gives us, I think this lands at around 50 frames a second, which compared to 60 is not far off from the typical sort of ideal frame rate of smooth animations. But yeah, that's what makes this smooth and not look choppy. Another thing that contributes to the smoothness on this is, if I pause it, you'll see it's not, well, I guess it's not actually that easy to see, but it'll do sort of anti-aliasing, where the LEDs will fade off and it's not just lighting up exactly one LED after the other. So it sort of gives it sub positions beyond what the raw pixels could give it if it was just full on and full off. One thing I noticed when I was putting this all together and putting the LED strips inside the track was that the ends of them weren't matching up exactly where I expected them to end up in the CAD model. They're just a little bit off. So what I ended up having to do was set up a calibration system where I could control the mapping of locations along the LED strip to exact points that I knew. So in this case, I put a bunch of points at every single track section boundary. And then once I had those all lined up, then I could ensure the simulation animation was going to run across the track exactly as I expected it and be in the right spot. Well, after all that does it for this project, and I hope you enjoyed. I'll just leave it with a little bit of a nice view of it going around.